Okay, question 3 is the proof by induction question. It's a sequences proof by induction question, so that's the first type that we went through in class. And in order to start off this question, we're going to start off with a base case. So we have to prove that it's true, prove that this is true, that this does equal this when n equals 1 for our first term here. So let's have a look. On the left hand side, we've got the sum of r equals 1 to 1. We're just going to have a 1 up here for the base case where n equals 1, which is r times 3 bracket r plus 1. Sorry, r bracket 3r plus 1. So that's going to equal, the first term there's only going to be one term, so it's just when r equals 1. So we've got 1 times by 3 lots of 1, which is 3, plus 1. So that's 1 times 4, which is 4. Over on the right hand side, when n equals 1, what do we get? We're going to have 1 times 1 plus 1 all squared, which is 1 times 2 squared, which is 1 times 4, which is 4 again. So we get 4 both times. So it is correct. So n equals 1 is true. Next thing we're going to do is we're going to assume that this is true from 1 to n. Up to k. So we're going to assume it's true for n equals k. So from r equals 1 to k. So we're going to assume that this, the sum, is equal to k bracket k plus 1 all squared. We're going to assume that that is actually true. And if that's true, we're going to try and show that it's true for n equals k plus 1. So the next term after this one. So let's find out. Sum of r equals 1 to k plus 1 from r times 3r plus 1. What's that going to be equal to? Well, that's going to be equal to the first the first k terms plus the k plus 1th term. Well, what's the k plus 1th term? The k plus 1th term is going to be k plus 1 it's when r is equal to k plus 1. So we're going to swap r for k plus 1 to get the k plus 1th term. So that's going to be that. This, we've assumed, is equal to k bracket k plus 1 all squared. So can we simplify this? We've got k plus 1 bracket 3k plus, got 3 times 1 and an extra 1, so 3k plus 4. They have a k plus 1 factor in common, so we can take that factor out. And that will leave us with k times k plus 1, because this is k plus 1 squared, plus this 3k plus 4 term, which is k plus 1 times k squared plus k plus 3k plus 4, which is k plus 1 times by k squared plus 4k plus 4. But this factorises. That is k plus 2 times k plus 2, or k plus 2 squared. And that's what we were looking for. That will be the sum of the first k plus 1 terms if this is true. Because if we were going up to k plus 1, and this was true, we'd end up with k plus 1, because n is equal to k plus 1, times k plus 1 plus 1. So that's what we've got. We've got k plus 1 times by k plus 1 plus 1. So it is true for k plus 1 if it's true for n equals k. So we've shown that it's true for the first term. And we've also shown that it's true for 2 terms in a row. So that means it's always going to be true because it's true for the first one, and we've shown that if it's true for any term, it's true for the next one. So if it's true for the first one, it's true for the second one. If it's true for the second one, which we've shown it's true because it's true for the first one, that means it's true for the third one. And we can just keep going like that, which means it's true for all n. So, just to finish off and get your 5th mark in this exam situation, we have to write a nice little conclusion. We've already started it. We've written, so true for n equals k plus 1 if true for n equals k. It is true for n equals k since it's true for n equals 1. And that shows that it's true for all n greater than or equal to 1.